Hello students, welcome back to another geometry video. You know the drill, pause the video, try this problem in your notes, and then unpause it to do it with me. So we are supposed to find the area of the polygon with these vertices. Remember, vertices means corners of the polygon. So I'm gonna graph these and see what shape we're working with. So D is at -3, 2, D. E is at 4, 2, whoops, that's E, E, and F is at 4, -3. So this is the shape we're working with. Beautiful. Now I want to find the area of this shape. And we know that the area of a triangle, because this is a triangle, I can tell that it has 3 sides. That makes it a triangle. So the area is 1/2 times base times height. So I just need to figure out what the base is and what the height is, and then multiply, and we're good to go. So let's see. The base. We talked in last video about how the base and the height needed to be perpendicular to one another. So I see, because we're on our coordinate plane, and in our coordinate plane, the y-axis is always perpendicular to the x-axis. So I can already see that this corner up here is indeed, DE is perpendicular to EF. So what I think we should do is let's find how long DE is. This will be our base. And then we can find EF, and that will be our height. So, let's do B first. Or excuse me, DE, the base, we'll do DE first. Because this is perfectly horizontal, I can take the absolute value of one coordinate minus the other. So D's x-coordinate is -3, and E's x-coordinate is 4. -3 minus 4 is -7, but the absolute value of -7 is +7. So look at that, our base is 7. And now our height comes from the segment EF, which is, now we have a vertical segment, we're going to use our vertical ruler, which is the y-axis. So E is at 2 on the y-axis. And F is at -3 on the y-axis. So now 2 minus a negative, we become positive. So this is the absolute value of 5. Absolute value just makes things positive, so that stays 5. And now our height is 5. Ta-da! Okay. And now we just have to multiply all of this beauty together. So, new color. We have, we're running out of space. Area is 1/2 times 7 times 5, which means that area is 1/2 of 35, which means that it is equal to half of 35. I know what this is. Why am I putting it in my calculator? It is 17.5. Now, because we're talking about area, we want to specify that this is units squared. These are square units. If I paint the inside of this triangle, I will need 17.5 square units of paint. Okay, there we go. We have found the area of the triangle. So, yay. On to what we have for today. Today is the first day on section 1.5, chapter 1, section 5. It is all about angles. All about angles. We've been talking about segments, we talked about lines, rays, planes, but we haven't talked about angles yet, and angles are huge in geometry. So today and tomorrow will be about angles. Our success criteria, our learning target, is that you know what angles are, how to use a protractor, and how to find congruent angles. Now, I know all of you might not have a protractor in your house, so I'm going to show you virtually how to use one so that you know, if you have one in person, you know what to do with it. But don't worry, you're not going to need a protractor for any of your homework. Okay, our success criteria is that you can measure and classify angles, and that you can identify congruent angles. So, be thinking about these things as we go throughout the lesson, because this is what we're trying to learn. Alright, vocab! An angle. What is an angle? First time we're officially talking about angles. An angle is a set of points consisting of two different rays that have the same endpoint, called the vertex. So you're going to see this a lot. The vertex is like the corner of a shape or an angle. I know in algebra, vertex was like the vertex of a parabola was right down there at the bottom. So vertex is kind of like the bottom of this V shape. But this vertex is different than the parabola vertices we talked about in algebra. Okay, so the rays are the sides of the angle. So you can see here, and please do put this picture in your notes because it tells you what a vertex is, it shows you what the sides are, and it illustrates very well that this is a ray. You can tell by that arrow on the end of either of these lines. An angle goes on forever in both of these directions. It goes on forever and it goes on forever because these are rays that make up this angle. Okay, so angles have a vertex and they have two sides. Now, you can name an angle in several different ways. You can use its vertex and just call it angle A. You can only do this if the angle looks like this. If I have another ray coming off the end of A, like say D, now if you say angle A, what angle are you talking about? Are you talking about this angle A? Are you talking about this angle A? Are you talking about this angle A? I don't know. I don't know which angle you're talking about. So if we don't have this ray right here, and you say angle A, oh, this is the only option for angle A. So when there's only one vertex, when point A is only part of one vertex for one angle, then you may call it angle A. But if we have this case, like here, you cannot call this angle angle A, because all of these are kind of like angle A, and I don't know which one you're talking about. Okay, so a better way to name angles, this one is confusing. When can I name it? When can't I, right? So instead of naming it that way, you can use a point on each ray and the vertex. So we can say angle BAC. And so we can say angle BAC. Ray, vertex, ray. BAC. Just like that. You can also call it CAB. So I can start at C and say angle CAB. See how it draws it out like that? When you say CAB, it's like connect the dots. It's like those fun connect the dots puzzles that you had as a kid. Or maybe you didn't. I don't know. But CAB. So if you connect the dots of C, A, and B, you will get an angle that looks like this. So that's another way you can name it. You can also just give it a number. You can put a 1 here, and you're like, all right, that's angle 1. If you're like, I don't want to deal with letters, angle 1. If you're not given a number, you could just give it a number. If the problem that you're looking at doesn't have a number there, you could just write one in. Or you can name it using the second way to name angles. You could just say angle CAB. So those are the 3 different ways to name angles. One more thing I think you should know about angles is the interior of the angle and the exterior of the angle. It is basically exactly what it sounds like. The interior of the angle is everything between these two rays. So all of this is the interior. The exterior is anything on the outside of those two rays. Kind of like being inside a house and being outside of the house. Everything inside of the walls is inside the house. So yeah, that's all I think you need to know about angles. Now, we're going to jump right into example 1, naming angles. A lighthouse keeper measures the angles formed by the lighthouse and 3 boats. Name 3 angles shown in the diagram. So, and we want 3 different angles. So, I noticed that there's this angle here, and in fact, let's make that a little bit bigger. We have this angle here, and I have this angle here on the bottom, and then I have the big angle all together. So, can I call these angle M? Can I call any one of these angle M? No. No, I cannot. If you say angle M, which one are you talking about? Are you talking about this one? Are you talking about this one? They all have an M in common. I don't know which one you're talking about. So, do not call them angle M. Instead, let's, I don't see any numbers. I don't see a 1 or a 2. So we could put the 1 and 2 in there and name them that way. Or we can say, I'm looking at this angle right here. JMK. So 1, we need 3 angles. So the first can be angle. You draw this little symbol that looks like an angle, and that means angle JMK. And that's this red angle. Now we can talk about this angle right here. KML. Or LMK. Same thing. Because when I flip it up and turn it around, it looks the exact same. You can go JMK, you can go KMJ. Doesn't matter. But the important thing is that the vertex is in the middle. See how M is in the middle? The vertex always needs to be in the middle. So, L, angle L, M, K. So we did it like this. We started at L, we went back to M, and then we went out to K. Angle LMK. Alright. And lastly, which color is going to show up best on this blue background? Yeah, let's do purple. Lastly, I want this big angle here. I want angle JML. JML. If you said LMJ, whoops, LMJ, that is also correct, but these are the same angle. JML, and LMJ are the exact same angle. It's just a different name for it. It's like when you say segment LM versus segment ML, it's the same thing. And we wanted to name 3 different angles. So, there we have them. Ta-da! Okay, next. Oh, yes. So see their solution? They had JMK or KMJ. They switched the J and the K around for each of their angled examples. And they said what I have stressed, when a point is the vertex of more than one angle, you cannot use the vertex alone to name the angle. So what this means is that you cannot call it angle M. Cannot call it angle M. Okay, moving on. We were right. Okay, important information. We saw the ruler postulate back in 1.2 about how to measure segments. Now we are measuring angles, and we measure angles with what's called a protractor. This object on the right is called a protractor, and the protractor postulate says the measure of angle AOB is equal to the absolute value of the difference between the real numbers matched with each ray on a protractor. So, absolute value of the difference. That sounds very familiar to the ruler postulate. So the absolute value of the difference between the real numbers on a protractor. So what this means is I'm going to look at this ray right down here. What numbers does this ray run into? It runs into 0 and 180. Which of those numbers do you want to use? It doesn't matter. See how there are numbers on the top and the bottom? There are these numbers and these numbers. It does not matter if you use the numbers on the top or the numbers on the bottom, as long as you are consistent. Don't pick the top number over here and the bottom number over here. You're going to get the wrong answer. So you want to do the top number over here and the top number over here, or the bottom number over here and the bottom number over here. If you're doing top, stay on the top. If you're doing the bottom, stay on the bottom. Okay. So 0 or 180. Let's do 180, since I like to think of 0 as over here, so it's like 0, 10, 20, 30, 40, and so on. So we'll use 180. So that is 180 minus the other number on our protractor, which is over here, I see. And we need to use the number on the top, because 180 was on the top over here. So the number on the top over here is 40. So 180 minus 40 is 140. The absolute value of 140 is 140. So the measure of this angle is 140 degrees. When we measure angles, we can measure them in degrees. Protractors always measure them in degrees. You can measure angles in radians, but we're not going to learn about that until chapter 9. So you don't need to worry about radians anytime soon. So degrees, 140 degrees. Okay, beautiful, beautiful. Let's classify angles, shall we? So the types of angles, maybe you've seen this before, maybe you haven't. I don't know. So I'm going to walk you through it. Acute angles measure greater than 0, but less than 90. And of course, all angles are greater than 0, right? Until you get to pre-calc, then you can have negative angles. But right now, we cannot have negative angles. So the way that I think about this is because they are less than 90, oh, they're so cute. They're little acute angles, aren't they so cute? You know, like people call cute, that like little things are cute. So acute angles are ones that are less than 90 degrees. I would like you to put all of this in your notes, but these words down here, you can just write down what I underlined. So acute, less than 90 degrees. Now, right angle is exactly 90 degrees. And I would even write that, exactly 90 degrees. If it's not 90 degrees, it's not a right angle. If it is 89.999, it is not a right angle. You need to be perfectly, exactly 90 degrees to be a right angle. An obtuse angle is greater than 90 degrees, but less than 180. And 180 degrees is a perfect straight line. That's why we call it a straight angle, because it's a line. A straight angle, which is also a line, because they're back-to-back rays, right, measures 180 degrees. So an obtuse angle is in between a right angle and a straight angle. And the way that I think about that is, look at that. That just looks obtuse. It looks weird. It looks obtuse. That's how I think about it. Okay, make sure that this is in your notes. This is very important information. We are going to be using this for the rest of the year. Yeah, chapter 9, chapter 11, chapter 7, chapter 5. Oh yeah, all the chapters. So make sure that you know about these types of angles. Now, we're going to put what we just learned into an example. We're going to measure and classify angles. So, it says, the problem is asking us to find the measure of each angle and then classify each angle. So if I ask you to measure an angle, I'm going to give you a picture like this that has a protractor with it. So you might not have a protractor in your hands, but you have this picture with the protractor. Okay, so GHK is our first one. What I'm going to do is, there's a lot going on in this picture. I'm going to pick out, where is GHK? G is here, H is here, and K is over here. So this is the angle we're looking at. Just by looking at it, can you classify it? Is this an acute angle? Is it a straight angle? What type of angle is it? Think about that. First, I'm going to measure it. So I'm going to use the numbers on the top. I like to use the numbers on the top. So G is at 0. So I have the absolute value of 0 minus, over here, oh, look at that. It's perfectly in the middle of 120 and 135, because we're using the numbers on the top. So this is 125. We have 0 minus 125. Because that's in absolute value, well, yes, so this is negative 125, but because it's in absolute value, it is positive 125 degrees. So what kind of angle is this? 125 is bigger than 90 degrees, but it's smaller than 180. So, yes, this is an obtuse angle. Ta-da! Okay, next one, JHL. Okay, so now here's J, there's H, and L is right up here. So now this is the angle I'm looking at, the red one. What type of angle do you think this is? Acute, right, obtuse? What'll it be? We're going to take the absolute value of the top number, 180, minus the other top number, which is difficult to see, but it is 90. 180 minus 90, and now I'm going to put that line back there so we know what we're talking about. Okay, 180 minus 90 is 90. Absolute value of a positive number is that number. So we are 90 degrees, exactly 90 degrees, which means this is a right angle. There you have it. Okay, last one for this example. L. So now we're back at L again. This is going to be way too much. Let's use the highlighter. L. Hey. There we go. Oh, why aren't you working? L, H, K. There we go. There we go. That's better to see. Start at L, go down to H, and back up to K. L, H, K. Okay. So, the number on top we already know is 90, and the number on top over here we already know is 125. So, 90 minus 125 is negative 35, and the absolute value makes it positive. So we have 35 degrees, which is smaller than 90 degrees, which makes this an acute angle. Ta-da! There you go. We're done because we measured each angle and we classified each angle. So we are good to go. All right, we can check and make sure that we were right. 125 obtuse, 90 right, 35 acute. Yay. Booyah. Okay. The last little section of our lesson should go pretty quickly. Remember when we talked about congruent segments had the same length or had the same measure? Well, congruent angles have the same measure too. So if the measure, that's what this means. This means the measure of angle A. So when we write M, angle A, it means measure of angle A. So how many degrees? And when we say measure of angle A equals measure of angle D, that means angle A is congruent to angle D. And remember that that's what this symbol means. Let me give you a close-up. Equal sign with a squiggle on top, that means congruent. Now, congruent things are very important. We're going to talk about this more in Chapter 3 and more in Chapter 2. More in Chapter 4, all the chapters. We're going to be talking about congruent figures a lot. So make sure that you're familiar with this symbol and what it means to be congruent. Have the same measure. Congruent angles have the same measure. So 35 degrees and 35 degrees. Both of the angles with these measures would be congruent. Okay, so our last example for today has to do with identifying congruent angles. So, remember when we had a segment and it was cut in half by a midpoint, and they put those little tick marks there to say the segments were congruent? That's what those tick marks meant. Well, do you see these red tick marks here? G has 1 tick mark, B has 1 tick mark, F has 2 tick marks, and D has 2 tick marks. That's how you know that angles are congruent. They're still tick marks, but they're kind of like semicircle tick marks, but we still call them tick marks because it's just a little boop, boop, a little tick. So the ones that have 1 tick mark are congruent to each other, and the ones that have 2 tick marks are congruent to each other. This one has 1 tick mark, and this one has 2 because they are not congruent. Obviously, G is acute and F is obtuse, so there's no way they're congruent. That's why I use 1 tick mark up here, and I use 2 tick marks down here. Okay, so now that you know all about the tick marks, let's start this example. Part A says identify the congruent angles labeled in the quilt design. Now this is a very funky looking quilt. I have made a couple quilts myself. My mom is a very talented seamstress. And angles matter very much in sewing. If you ever get the chance to talk to my mom, or if I ever get her on a video, whoo! Angles. So many angles in quilting. Okay, so identify the congruent angles labeled. And those labels I was telling you about are these tick marks. So because angle G, and I can call it angle G because there's only one angle G. There's no other vertices with angle G. So angle G has 1 tick mark and angle B has 1 tick mark. So I know that these are congruent. There you go. And angle F has 2 tick marks and angle D has 2 tick marks. So these are also congruent. There you go. Part A is done. Let's get a new color. Part B. It says the measure of angle ADC is 140 degrees. So let's see. Let's find ADC. ADC is right here. So this... Oh, that is so hard to read. Let's get a different color in here. 140 degrees. So much better. There we go. So it says, if the measure of angle ADC is 140 degrees, what is the measure of angle EFG? Well, where is angle EFG? It is EFG. Aha. So it's that angle. And wait a minute, these tick marks tell us that they're congruent. If they're congruent, they have the same measure. So if this one's 140 and they're congruent, this one also better be 140. So part B, the measure, and remember that's what the M means. The M is the measure of angle EFG is 140 degrees. Because they're congruent. And congruent means that they have the same measure. Okay, let's make sure that we were correct. So, 2 pairs of congruent angles, and EFG is 140. So, booyah. Okay, if you have any questions, be sure to ask someone about them. Don't let them sit and fester. If you have questions now, you're going to have a whole lot more questions later if you don't ask for help. So please ask for help. Asking for help does not mean that you're weak. It means that you're strong enough to ask for help, and you're strong enough to take care of yourself when you need to. So, ask questions. These are practice problems that you can do to practice the skills that we have learned in this video. These might be different than the problems your teacher assigns, so do the problems your teacher has assigned before you just do these. All right, and our launch for today says it's okay to make mistakes. It is okay to have bad days. It is okay to be less than perfect. It is okay to do what's best for you. And it's okay to be yourself. I could break down each one of these things into smaller components. Mistakes help you grow. You learn from your mistakes. So mistakes are not a bad thing. Bad days. We all have them. Bad hair days. We say things that we shouldn't have said. We make mistakes. That's okay. Next day will be better. Nobody's perfect. You hear that said all the time, right? Hannah Montana had a big song about it. Nobody's perfect, but somehow we still feel like we're supposed to be perfect. As soon, I don't remember, it was after high school. It was not in high school. I don't remember when it clicked for me that I will never be perfect. And people gotta deal with it. Like, no one can expect you to be perfect. You're not gonna be. And that's okay. It is okay to be less than perfect. It's okay to do what's best for you. If there's somebody in your life that is just not healthy, not good for you, it is okay to ask them to step away. Or it's okay to step away yourself. It's not selfish if it's what you really need. And it's okay to be yourself. I was bullied a lot in high school for being myself. And I could have cried about it, but instead I said, like, you know what? This is me. This is who I am. If you don't like it, leave. You don't need everybody to like you. You're a peach, and some people don't like peaches. And that's okay. Not everybody has to like peaches. Not everybody has to like me. But I'm gonna be myself because you're happiest when you're yourself. If you keep trying to change yourself to be somebody else's idea of perfection, that's no fun. That's no fun. It is very fun to be yourself. And nobody else can be you. And you matter. And I didn't believe that in high school, but now that I'm teaching myself and I'm making a difference in the world, I believe it. I believe that I matter. So it might not feel like you matter right now, but you do. And especially, I mean, even if you're not one of my students, absolutely, but each and every one of my students, you matter to me. If you matter to nobody else, you matter to me. So, that is my launch for you today. It is okay. Next time you're stressing out about something, okay. That is my launch for you today. Take it with you as you go throughout your day. Have a wonderful rest of your day, and thank you so much for being here. Thank you for watching. Bye.